Hello everyone, welcome back to another episode where we build a game in LÖVE 2D. So first of all, I want to wish everyone a very happy New Year's and hope you had a wonderful New Year's Eve celebration. I know I'm super excited for 2025. I think we accomplished a ton in 2024, been learning how to code and learning how to do game development. And we've gone so far with our game that I'm really excited to kind of get to the next steps. Last time what we did is we implemented what I call the brute approach to create our trees. If you remember, before we did the brute approach, we all the trees had the same animation. So if you burnt one tree, all the trees burnt. Now they're actually independent from each other. But we use essentially an ID system to identify each tree. And what you'll actually notice is, for example, if I burn this left tree and then this right tree, they actually disappear at the same time, and they actually have the exact same animation because those are global variables in our code. The animation is global and the timer is global. So what we're actually going to do today is we're going to take our game to the next level and fix some of these bugs, which, you could consider them bugs. You could also consider them features. They're definitely bugs in my eyes. But essentially what we're going to do is we're going to use object-oriented programming to create each tree as an independent object from each other. And what each of these trees are going to have is they're going to have independent behavior from each other. And so we're going to essentially use classes. And this is actually really a powerful tool because it's going to allow us to scale our game very quickly. So we'll build the trees as classes, and then we'll build the Yeti as a class, the skiers as classes. Everything is going to become a class to essentially scale our game very, very fast and very, very well. All right. So without further ado, let's get started. So the first thing I did that you didn't see is I created a lib folder. And inside our lib folder, I moved a library called knife. We'll go over what knife does a little bit later in the video, but what I'm going to first do is I'm going to create a tree.lua script. And so this is where we're going to create our class. So to create our class, essentially we're going to create a tree class, which is going to call it tree. And it's going to take a class object. And if you remember from when we created our animation object, let me just pull that up. Down here, we essentially create an init function, an update function, and a getFrame function. So the init function is important because that's kind of our class constructor, where essentially we're going to define all the parameters that go into defining what this class represents. So we're going to do that for the tree, and then we're going to define a bunch of functions that essentially are going to be the behavior of our tree. So think of like changing the animation, or drawing the tree, or removing the tree from the map, etc., etc. So while I'm here, I'm actually going to move our animation code into a class, into a script of its own. So I'm going to call it animation.lua. And this is just some code cleanup that we're going to do really quick. So the thing is, when you move things into its own scripts, we need to call them back. So we're going to do require up here. And so we've got lib, so our pointer where we've saved the file. So lib animation, and then we need to bring in our tree, or lib tree. Perfect. So our tree, what we're going to do is we're going to create a bunch of functions right now. So tree init, so it needs an init. And it's going to take an input variable. We need our tree to have a update function because our tree has different behaviors that we need to make sure we capture. And then we need to draw our tree. So we're going to create a render function. And so one of the things I like to do to understand what this class represents and what are the parameters I need to put in, I like to go to main and take a look at what we've already done. And so look for all of anything that refers to our tree. So you can see our tree has two animation objects, one for the idle tree animation and one for the burning tree animation. So we're actually going to need these. So I'm gonna move them over to our tree class here. The next thing, if we scroll down a little bit, you'll see that we have an X tree, Y tree, there's a state, there's a body, a shape, a fixture for our physics collider. So essentially we need all of this. So I'm actually just going to also copy paste all of this over down here. If I keep going, you'll see we're actually updating the animation, but that's calling the update function. We're going to call it on our tree object. If we keep going, we need a tree timer. So I'm going to bring the tree timer in here as well. We don't really care about the destroy tree. I'm actually also going to comment all of this code out because we are no longer going to use it. Keep going. We had our contact bodies for our tree, but that we actually don't need to. That was we're capturing like which tree the Yeti collided with. And then if we look at our draw here, we actually need a lot of stuff from here. So I'm gonna bring this one over here as well. So what we need is our sprite sheet. We need the frames and essentially a pointer to the texture. So the tree texture. So if I go back to our main, here's our sprite and our frames. And essentially all of our tree drawings are referring to this tree structure here. So we essentially need a tree, we need a reference to tree here. So this is actually our tree animation object, and the animation object has a get frame function. So we'll need to, make sure we bring that in. The X and Y, and then we essentially have an angle, a scale X, a scale Y, the offset X, and the offset Y of the tree. So these are, like what I've done just now is listed all of the parameters that define what a tree is in our game. And so we're going to need to bring all of that inside of our init. So to do that, I'm going to cheat here because I've already prepared it somewhere else. So I'm just going to copy paste it in here. So we're going to go through here. So the world, right, since we need to create a physics object, and when you create a new body, you need to pass in the world. So we're going to take our world. And that's why our input is a table that's going to have a variable world. The self.atlas refers to the sprite sheet. It's just like a synonym. It's just shorter and sounds cooler. And so our input object or variable or table is going to have an atlas key as well. Our X and Y are the same as what we had in the code before. The body, the shape, the fixture, that's all of our physics objects that we're creating. We're adding our user data tree. You'll notice here we don't need the ID anymore. We've got our tree state. I'm actually going to make it more general because now it's hidden inside of our tree class. So timer. And then what you'll see here, we've got our texture, which is just tree. We have an empty table for animations. I'm going to talk about that in a minute. And then we have our current animation, also talk about that in a minute. We've got our offset X and Y, which is the same as what we have in our main currently. And then if you see here for angle, scale X, and scale Y, as well as entity animation, we're referring to something called tree defs. And just by looking at this, what you can tell is that tree defs is a table that has a key that points to our texture. And so you can see here there's a table with a key that's called tree. And then it has, that's another table. So it's a table inside of a table. And that table has keys called scale X, scale Y, R, and anims. So essentially what we've got, right, is a table inside of a table that's kind of got data for our tree. So let's build that. because we need to. So treedefs.lua here. So it's going to be treedef, and we said it's a table, and it has a key, the key our tree, and that's another table. And then this table has an R value, a scale X value, a scale Y value, and then an anims value. So our R, scale X, and scale Y are actually just our angle and then our scales. So in this case, 0 to 2. So if I go here, our R is just 0, our scale X is 2, and 2. Now our anims is a little bit more tricky, because essentially what we have, right, if we look at our tree, we have 2 animations. And these are actually animation objects. And what we need to do is we need to be able to create these animation objects. If not, we're not going to be able to have those animation objects. But to create those animation objects, we need to define like what are the frames as well as what are the intervals between our frames that we want to have. So what we need to do is inside of our anims is a way to refer to the idle tree animation parameters, which is these 2 frames and intervals, and then our burning tree animations, frames and intervals. So inside of treedef, what we're going to do is anim is actually going to be another table. So now we've got a table inside of a table inside of a table, tableception. And what we're going to do is we're going to call this one idle tree. Oops. Idle tree, there we go. And that's going to be a table as well. And what it's actually going to be a table of is the information that's needed for defining what an idle tree animation is. In this case, the frames and the interval. And we're just going to essentially copy this whole thing and do a burning tree animation definition here. I think burning tree was 4, 5, 6, and 7 with 0.2. There we go. And so this is actually a really powerful way to organize your data, because so what we've done here is we defined a tree. But if we had like multiple trees in our game, what we could do is we could essentially copy this tree definition down here. Let's say we had an apple tree. I'm going to do apple tree. And apple tree had a scale of 3 on the x-axis and then maybe 6 on the y-axis. And then it's got its own animations with different frames, etc., etc. Now what we can do is all we have to do in our tree class is change the texture from tree to apple tree, and we can bring in all of that apple tree data in and create an apple tree. So all we did is just add a table definition of what an apple tree is. We didn't have to write new code. And so that makes the code really reusable and very scalable when we start creating a lot of different objects or entities for our game. So for now, I'm just going to remove the apple tree. But hopefully this makes sense. And you'll see once we start making classes for everything in the game, this will really help us. Okay, so now we've actually created and reviewed all of these. So I'm actually going to delete all of this. And we've got everything we need to create our tree. So one of the key things for our tree, right, is the animation. Essentially, we've got really 2 states. We've got the dancing state of the tree and then the burning state of the tree. Actually, we have 3 states. We have the dancing state, the burning state, and then the disappeared state, like it's gone from the game. So we essentially need to store all of that information somehow. And so those animations, they're defined by their states. Those states are defined by their animation. That's kind of like how you recognize what state you're in. And so we have really two animations that we need to render to the screen. And so what we actually did is we created an empty table for our animations. And what we're going to put in here is the actual animation objects. So if you recall here, we were creating animation objects for both the idle tree and the burning tree. What we're going to do is we're going to create those animation objects again. And instead of storing them in variables, we're going to store them in this animation table that will have the keys being idle tree and burning tree. And then we're going to refer to whether we're in the idle tree animation or the burning tree animation using the current animation. So we're going to essentially create two new functions. We're going to create one where we add animations to our animations table, and then another function where we update what current animation we're in to essentially update the rendering of our tree. So I'm going to create a function here, create animation. It's going to take an animation name, and this one is actually pretty easy to actually build. So what we're doing, right, is we're adding new keys to our empty table. And so to do that, we just call the table, pass in the animation name that's being parameterized in our function, and then we just call the animation class because we're creating an animation object. And if you recall, that takes a frame or frames, and we saved all of that frame information inside of our tree defs anims inside of entity animation here. So all we got to do is call our tree entity animation, whatever animation we're referring to, and then call the frames of that. And then it's kind of frustrating. It never indents by itself. There we go. And then we're essentially going to do the same thing, for our interval, just like that. And just for transparency, essentially, I'm referring to this idle tree, frames, and interval. So the self-entity animations refers to essentially this whole table here. The animation name parameter is referring to whether idle tree here or burning tree here. And then the pointer frames and intervals refers to frames and interval here. Perfect, and that's all we need to do. So if we call create animation, pass in an animation name, it's going to create a new animation object here. And then for changing the animation, right? So if we want to go from the dancing tree or idle tree to the burning tree animation, all we got to do is update the value of the current animation. So if our animation name is different than the current animation, which is initialized as a empty string, then all we want to do is update the current animation to being the animation name, just like that. And then finally, in our update function, what we want to do is we just want to update the animation. So we just do self.animation, where we've saved our animations object. We want to point to the current animation, and that essentially refers to the animation object, and that has an update function. If you remember here, this is the update function, where it just cycles through each of the frames. Perfect. And then lastly, now we essentially want to draw our tree to the screen. So here, what we need to call is our love.graphics.draw function. It's going to take our atlas or our sprite sheet. So I'm going to do self.atlas. And then essentially it's referring to our G frames. So essentially the frames where we've saved our tree drawings. It's going to refer to the tree drawings. And then we essentially need to call our animations, the getFrame component. So I just do self.animation current animation and then call the getFrames, just like that. Oop. And then essentially we need our x, so self.x, self.y. Oops, not Yeti. We need our self.angle, self.scale x, scale y. Oop, I wish I could type faster. And then finally our offset x and self.offset y. Perfect. So now we essentially have our whole tree class defined, and we're pretty much good. So what we can do is let's create some trees. So we're still going to create 6 trees, and what we're going to do is we're going to put our tree objects inside of our tree table. But instead of kind of creating our trees like we did before, we're just going to call the tree class, and it takes an input. The input being the world. It's a table of the world and of our sprite, right? So I just need to do input, create a table. So I need to make sure I use curly braces. World equals world, and then atlas, because we call it atlas, equals sprite sheet. So here, now that we've created our tree, we've created 6 tree objects. We need to make sure that we create their animations, because if you remember, the animation is initiated as a empty table. So we call the create animation function idle tree. We need to create 2 animations, so we also create the burning tree. And then we remember the current animation selected is an empty string, so we need to make sure we change the animation to our idle tree animation. Oops. Perfect. So here, essentially, every time we were referring to our tree xy, we need to update that to our tree table. And we no longer need to call, we just need to call the object, because the object has an update function. So tree update, just like that. Let's keep going. And here, same thing. But instead of calling the love.draw function, now we just refer to the render function that the tree object has. So we can just do tree render, just like that. So now if we actually run it, we get an error. Oh, you know what? I forgot to source our tree defs. So I also need to do require lib tree defs. There we go. Oop. Perfect. And so now we got our dancing trees. You'll notice that when I press the return key, nothing's going on because we've just been drawing the trees. We didn't actually implement any of the burning tree logic yet. So for our burning tree, there's a couple things that happen, right? We essentially need to change the animation, and then we need to destroy the physics body, and then we need to remove the tree from the screen. So because the physics, the physics body of the tree is defined inside of our tree class with the self.body, we can destroy the body directly in the class. Because the tree is assigned to the tree table inside of our main, the only way to destroy the tree or remove the tree from the screen is going to be in main. So inside of our tree class, what we're going to do is we're going to create a new function. We're going to call it tree removal. And what that's going to do is it's actually going to change our tree animation to the burning animation. Oop, burning tree. And then it's going to destroy the body, the physics body of the tree. And so this is actually where I want to bring up knife. So I brought in the knife library because it has this cool class called timer. And inside of timer, there's this function called timer every, which actually allows us to loop over and over and over given a specific time frame. And then every time it loops, it runs a function. And the cool thing is that you can actually also once it's done looping, like you can define how many times you want it to loop. Once you're done looping, it can do another function that essentially gets triggered when it's done looping. So to do that, we're going to do timer. Oh, let me actually bring it in first. So I need to go back up here. And we're going to create a timer object. So it's going to require, and then we're going to do lib knife.timer. So this is how we're bringing in our timer class. And so here, what I'm going to do is I'm going to do timer.every. And so we want it to happen every 1.15 seconds. And what we actually want to do is we want the physics body to get destroyed. So we're going to check if the physics body is not destroyed, then destroy it. So self body is destroyed. This is going to return true or false if it's not been destroyed. So if it's not been destroyed, then we want to destroy it. Boom. And this is how we remove our colliders for that tree. And end. After we've done our loop, we want to finish by changing the tree state. So once it's done running, we wanted to create a function, or we wanted to run a function where essentially it's going to change the state of the tree from state 1, or state 1 is the idle tree, state 2 is the burning tree. So we're actually going from state 2 to state 3, which is the tree being removed from the map. Just like that. And what we want it to do is we just want it to run one time. If we run it more than once, it's going to error out because the physics body has been destroyed already. So it doesn't exist anymore. Perfect. And so now in our main, what we're going to need to do is we're going to need to, I'm actually going to delete all of this code. We no longer need it. I'm going to delete this code as well. So what we're going to do is we're going to check if the tree, so first we're going to check each tree. So for I tree in pairs of our tree table. So if our tree is in the state 2, that means in the burning state, then we want to check if the users pressed the return key. So love.keyboard.isDown return. Then what we want to do is we want to call the tree removal function we just created. Oh, I need to put an end here. And then if it's not in state 2, but if it's in state 3, what we want to do is we want to remove the tree from the game. So we do tree table.remove and tree table, and we just want to remove the ith element. Oop. There we go. So one of the key things here, right, is we're checking if we're in state 2, and then we're checking if we're in state 3. The problem is, how do we get to state 2? Because if we never make it to state 2, we're never going to be able to call the removal function, and we're never going to be able to remove the tree. And so that's actually where we go into our collision detection code. So begin contact and end contact. And what we're going to do is we're going to check whether or not the tree has collided. And if it's collided, we're going to change the state from state 1 to state 2. And if the collision ends, we're going to go from state 2 back to state 1. So we're going to do for I tree in pairs tree table do, and then if the body of the tree, so you do tree.body, is equal to the tree fixture body, then that means that it's found which tree is colliding with the Yeti. Then we're going to change the tree from state 1 to state 2. Just like that. Oop. And this is the exact same code we're going to use to end our collision, except instead of going to state 2, we're going to go back to state 1. So essentially, if you collide with the tree and you don't press the return key, you'll go back to state 1. All right, let's try it. So we got our dancing trees, we got our Yeti, and I press the return key, and the tree is forever burning. Okay, well, so we're actually going into state 2, which means that we are calling our removal function. So we are able to do this. What we're not doing is doing this. So if I go here, 1.15 seconds. Oh, you know what? I think I know. So timer needs a delta time to run. So we need to call a timer update. So we need to do timer.update delta time. So this is just going to update our timers for all of our game timers. So anytime we call the object timer, it'll get updated by delta time. All right, let's try this. Hopefully this is what was wrong. Ooh. All right, now we have a different bug, the is destroyed bug, and I think it's because I need to capitalize. I need to capitalize it because it doesn't know what is destroyed, lowercase d. There we go. And so now you can see that our trees are burning independently from each other. Let me actually reload it one more time to show you. So if I start with this left tree and then this right tree, they don't disappear at the same time. They have their own burning animation. They actually all have their own timer animation. And so that worked really well. So that's pretty awesome. And what we've actually done is we've kind of planted the seed to create a lot of class objects. So we're going to essentially do that for our skiers, for our Yeti, like I said at the beginning of the video. We're going to do that for a lot of other things in our game. And what I'm excited about is this is going to allow us to really expedite and get kind of world building for our game much faster as well as much better. So I'm super excited for our future videos where we start doing that. And I'm also very excited to kind of start adding more content to our game. I think we've added our trees, skiers, and Yeti. I'm pretty excited to look at our sprite sheet again and decide what should we include. And with that said, if you have any suggestion on what you would like to include, feel free to leave a comment. And as always, if you found this content helpful or interesting, please like, subscribe. Thank you so much. It's like that.